Good afternoon, everyone. Today we're going to look at another arithmetic sequence where we're given the fact that the 15th term, T15, is equal to 43, and the sum of its first 15 terms is equal to 120. So S15 is equal to 120. And we are tasked with figuring out the values for its first, second, and third terms. Okay? So first things first, let's write out the equations that might be useful. We know that Tn is equal to T1 plus n minus 1 times d. We know that Sn is equal to n over 2 times the sum of T1 plus Tn, and we know that Sn is also equal to n over 2 times 2T1 plus n minus 1 times d. Now, with the information that we have the 15th term and the 15th partial sum, right? Now, right away, you might notice that that would be a good candidate for this version of the Sn formula because we have Sn accompanied with Tn, right? We know that because n is the same subscript in both, which is what we have going on here, okay? So that means that we can use that form of our Sn formula and we can plug in for S15, right? With this formula, we can say that S15 is equal to 15 over 2 times T1 plus T15, right? In a general sense, we are simply replacing n with a specific value all the way through. And now we know S15, that is 120, so that's equal to 15 over 2 times T1 plus T15 is also given to us, right? That's 43. And so if we just plug those in, we have a pretty straightforward equation to solve, right? The only unknown in this equation is T1, and that's one of the values that we're looking for. And so let's go ahead and solve this algebraically. First thing I would do is maybe multiply both sides by 2, get rid of the 2. So 120 times 2 is 240, and that's equal to 15 times T1 plus 43. Now, there are a few different ways to go about this, but I'm gonna rather divide both sides by 15 to simply cancel out the 15 in front of the brackets. And we do the same thing to both sides. 240 divided by 15 is 16. So we have 16 is now equal to just the T1 plus 43. And of course, to finish that off, subtract 43 from both sides. And we end up with T1 being 16 minus 43 is negative 27, okay? Now, that's only T1, right? T1 is equal to negative 27, okay? So now we have T1, we want T2 and T3, so the only way for us to find T2 and T3 would be to know the common difference, to know the value of D, right? So now, there are a few different ways we can do this. Maybe the easiest way would be to use T15 in this formula, and then we can solve for D. Because we'll know T15, that'll make n 15, right? T15 means n is 15, so n is 15 in here as well. We'll know T1, we found that to be negative 27, and so we'll be able to solve for D. So let's go ahead and do that. Let's plug in this into here, and that would mean that n is going to be equal to 15 in this case. And so using this formula, we get 43 is equal to, right, because T15 is 43, so I'm replacing T15 with the value 43 for n is equal to 15 in there. So 43 is going to be equal to T1. T1 is negative 27 plus, again, the n minus 1 becomes 15 minus 1 times d. D being the unknown that we are currently solving for. And now we're back to good old algebra. So d is in this term. Let's get rid of the minus 27. Add 27 to both sides. Add 27, so 70 is equal to 15 minus 1 is 14, of course. And so we have 70 is equal to 14d. Divide by 14 on both sides to cancel out the 14. And we get a common difference, a d value of 5. And now, of course, we can apply that to T1 to get T2 and T3. Let's do T2 is simply T1 plus D, and so T2 is negative 27 plus 5, and so T2 is negative 22. And of course, T3 is T2 plus a common difference, and so T3 is negative 22 plus D of 5, and so T3 is negative 17. And there we have it. We have T1, T2, and T3. I do hope this helps. I hope you're starting to connect some dots with arithmetic sequences and series, learning how to go through the algebra with different scenarios. If you guys have any other problems in this section you'd like to see done out, please let me know in the comment section, and thanks for watching.